Hello and welcome. Today we're going to be talking a little bit more about simplifying polynomials. We've talked in our past couple lessons about adding and subtracting polynomials, multiplying polynomials, and raising monomials to powers. Today we're going to continue combining those ideas together. First, I'd like to recall how to simplify expressions such as these. Remember to focus on just one thing at a time as you proceed in simplifying. First thing I'm going to simplify is the 6 and the 12. 6 reduces to a 1 and the 12 reduces to a 2. You may rewrite what you have left if you'd like. I have 1 p to the negative third, w to the fifth on top, over 2 p to the fourth, w to the negative seventh. Remember, those things that have negative exponents are on the wrong side of the fraction bar, so I need to move them to the other side. I'm going to move the p from the top down and the w from the bottom up in the same step. So on the top, the p went away, and I have w to the fifth. That w to the seventh comes up, so w to the seventh, over 2p to the fourth. The w went away, but I had brought this p to the third down, so p to the third. Now going one step further, I can combine the w's on the top and the p's on the bottom. Since we are multiplying and the bases are the same, I add the exponents together. So I end up with w to the 12th power on top and 2p to the 7th on the bottom. This is as simplified as we can go, so we stop here. On the right, very similar, except I'm going to focus on one fraction at a time. The 14 and the 21 reduced by 7 to get 2 and 3. Also, if you'd like, you may move the x to the second down and the y to the third up since the exponents are negative. So on the top, what I have is 2. That x moved down. I have y to the fifth, and the y to the third came up. The exponent's now positive. On the bottom, I have a 3. My x to the second came down to join my x to the third, and that y to the third is gone. I'm going to go ahead and simplify this one step further by adding the exponents on the y's in the numerator and on the x's in the denominator. So in the numerator, I end up with 2y to the 8th, and in the denominator, I have 3x to the 5th. Times, I'm going to go ahead and simplify the fraction on the right. 24 and 20 can both reduce by 4. The 24 becomes a 6, and the 20 becomes a 5. In the same step, I'm going to go ahead and move my x to the fourth down and my y to the second up. So on the top, I have 6. My x to the fourth went down, so I have y, and my y to the second came up. Over, on the bottom, I have a 5. My x to the fourth came down to join my x that was already there, and this y went away. So in the numerator, multiplying my y's, I have 6y to the third power over 5x to the fifth power. From here, I multiply across, or if you'd like, you may simplify across the two fractions. I'm going to go ahead and do that. I see that the 3 and the 6 reduce to a 1 and a 2. Once I've done that, I'm going to go ahead and multiply across, and my fraction should be as simplified as possible. 2 times 2 is 4. Y to the 8th times y to the 3rd. Since we're multiplying, I add the exponents to get y to the 11th. Over 1 times 5 gives me 5 as my coefficient. And x to the 5th times x to the 5th. Again, since I'm multiplying, I add the exponents, and I get x to the 10th power. As you should notice, nothing is going to cancel out, so this is my most simplified form. Down below, I'm going to take the 4, the exponent on the outside, and apply it to everything on the inside of the parentheses. So I have negative 2, all raised to the 4th power. I have x to the 3rd, raised to the 4th power. And I have y to the 6th, raised to the 4th power. Negative 2 to the 4th is a positive 16. As we've talked about in previous lessons, when you take an exponent and raise it to another exponent, you're simply going to multiply those two together. I have x to the 3rd raised to the 4th power, Multiplying the exponents, I get x to the 12th power. Similarly, I have y to the 6th raised to the 4th power. Multiplying those exponents, 6 times 4 gives me y to the 24th power. Our last problem on the right is very similar, except instead of a -2 in front, there's just a negative. But remember, there's an invisible -1 in front of the w. So what we end up having is -1 raised to the 7th power. Applying that 7 to everything inside my parentheses, I also have w to the 4th raised to the 7th power, times v to the 5th raised to the 7th power. -1 to the 7th power, or -1 multiplied by itself 7 times, still gives us a -1. W to the 4th raised to the 7th, when I multiply those exponents, I get w to the 28th power. V to the 5th raised to the 7th, multiplying those exponents, I get v to the 35th power. If you'd like, you may go one step further and write this as simply -w to the 28th, v to the 35th. It's not necessary to write the 1 as it's implied. What we are going to do is start combining concepts now. As you can see, I have a monomial multiplied by a monomial, but the second monomial is being raised to the 2nd power. So first thing I'm going to do is simplify the monomial that's being raised to the 2nd power. If you follow your order of operations, the first thing we need to do is look inside parentheses. However, looking inside our parentheses, there's not much we can simplify. So we move on and we look at exponents. When I look at my exponents, I cannot do anything with the y to the 3rd. I cannot do anything with the x to the 2nd or the y to the 4th. However, I can do something with this exponent on the outside. So that is the first thing I'm going to do. I'm going to take that 2 and apply it on everything inside my parentheses. -5 to the 2nd power, x to the 2nd power, raised to the 2nd power, and y to the 4th raised to the 2nd power. Gives me 25, x to the 4th, and y to the 8th when I multiply those exponents. This is all being multiplied by the monomial in the front, which was 3x y to the 3rd. Multiplying my coefficients, 3 times 25 gives me 75. X times x to the 4th gives me x to the 5th power when I add the exponents. And y to the 3rd times y to the 8th gives me y to the 11th power, again adding the exponents. This is our most simplified version. Similarly, down below, before I can multiply the two monomials together, I need to take care of the exponents on the outside of each by applying it to everything inside. From the first monomial, I have 3 to the 2nd power times x to the 5th raised to the 2nd power times y to the 7th raised to the 2nd power times I have a -2 from my second polynomial raised to the 3rd power times x to the 4th raised to the 3rd power times y raised to the 3rd power. 3 to the 2nd is 9. X to the 5th raised to the 2nd is x to the 10th. Y to the 7th raised to the 2nd is y to the 14th. And now I'm here on the second half. -2 raised to the 3rd power is going to give me a -8. Since I'm multiplying, I'm going to go ahead and put it in parentheses. X to the 4th raised to the 3rd is x to the 12th power. And y raised to the 3rd is still y to the 3rd power. Now I'm multiplying everything together. So I'm going to begin by multiplying my 9 and my -8 to give me -72. From there I multiply my x terms together, x to the 10th times x to the 12th. Since we're multiplying and the bases are the same, I add the exponents to get positive 22. And lastly, y to the 14th times y to the 3rd gives me y to the positive 17th power. Since there's nothing further we can do to simplify, This is the most simplified version of our polynomial. Similarly here, I am going to simplify each of the monomials individually and then add my results together. So first thing I'm going to do is take this exponent of 3, apply it to the 5 and to the x squared. I end up with 5 to the third times x squared to the third power, which gives me 125 times x to the 6th power. On the right, I'm going to take this 2 and apply it to the 5 and the x to the third. So I have plus 5 squared times x to the third raised to the 2nd power. So down below I have plus 5 squared is 25, and x to the third raised to the 2nd gives me x to the 6th when I multiply those exponents. Now recall, in order to add two polynomials, you must have the same variables with the same exponents. So here I have x to the 6th and x to the 6th. Since my variables and exponents are the same, these are like terms. Since they are like terms, I can add them together by simply adding their coefficients. So I have 125, I'm going to add 25, and I get 150. Since I am adding, my variable and exponent do not change, so I have x still raised to the 6th power. Down below, very similar. I apply my exponent of 2 to everything inside the parentheses. I get 6 squared times x to the 4th squared, plus, on the right, I have negative 3 squared times x to the 3rd squared. 6 squared is 36. X to the 4th raised to the 2nd power is x to the 8th when I multiply the exponents. Plus, negative 3 squared is a positive 9. And x to the 3rd raised to the 2nd power is x to the 6th power. Now if you notice, these are not like terms because my variables and exponents are different. So this final binomial is the most simplified version that we will be able to obtain. So we stop here. Go ahead and take a second to pause the video and try this slide and the next slide on your own. I will put your answers up in just a moment for you to check your work. Your first should have simplified to 48 x to the 20th y to the 30th. The second should have simplified to 2x to the 3rd y plus 75 x to the 3rd y to the 4th. Since the y's do not have the same exponents, you may not combine this any further. On the next slide, the first should have simplified to negative 40 x to the 14th minus 3x to the 21st. Again, since the x's have different exponents, you may not combine these any further. And below, x to the 9th y to the 8th plus x to the 8th y to the 6th. Since those are not like terms, you may not add them together. Thank you so much for watching. I hope you guys have an awesome day, and I'll see you at our next class meeting.